Hi, welcome to LEPAK chapter 6. So, in this video, we are going to solve question 1a. So, what we have in the question is a single component circuit consists of a 1 kilo ohm pure resistor is connected to an AC voltage. The voltage across the resistor varies with time as shown in the figure 1. So, in this question, we have a single component circuit. What does this single component circuit means? That you have only one component connected in this circuit, which is the pure resistor. So our circuit is going to look something like this, where you have a resistor connected across an AC voltage. So this is our single component circuit. And this pure resistor has a value of 1 kilo ohm. The question asks us to calculate the peak current flowing through the resistor, to calculate the RMS current, and to write an equation for the AC circuit. So we have three different questions here. The first one is to find the I naught. Peak current here means I naught. And then we have RMS current, which is the root mean square current, and also to write the equation of the AC current. Okay, given also in the question a graph of V versus T, where the time here is in the unit of millisecond. Okay, for us to answer this question, first what are we going to do here is that we are going to identify the term given in the graph here. We are going to compare the graph given with the general graph, where from there we can deduce that when we have a graph of V versus time changing sinusoidally according to the AC, this positive 12 volt here indicates that this is our maximum voltage V0 here, and the same thing here, this is also our maximum voltage but in the opposite direction, negative V0, and the time taken for one complete cycle here is the period. Okay, so this is our period here. So period is equals to 20. So we have period over 2, and this is 2 times the period, 3 over 2 here. Okay, so this is what we have here. So based on the graph, we can deduce a few information such as our V0 here is 12 volt, our period here is 20 millisecond. Okay, so now we are going to answer the first question, which is the peak current. So we're going to find the peak current. Based on what we have deduced earlier, we have V0 is equals to 12 volt, and also period is equals to 20 millisecond. These are the information we have from the graph, and in the question we have our resistor is 1 kilo ohm. So we need to find the peak current I0, and as you can see, we have Ohm's law, which is relating the VI and also R here. In the question, we are looking for I0, whereas V0 and R is given in the question. We are going to rearrange this Ohm's law equation to get I0 is going to equals to V0 over R, where the V0 is 12 volt based on the graph, and also we have the resistance as 1 kilo 10 to the power 3. Okay, remember this is the prefix 10 to the power 3, and then we can press our calculator to get the answer for the I0, which is 0.012 ampere. Okay, next we are going to look at the second question here. We need to calculate the RMS current, and the information we have here is V0, the period, the resistor, and also I0. These are the information that we have given and also we have collected. So now we are going to find the RMS current. So for IRMS, we have a specific equation to find the to find the root mean square, which is I RMS is given as the peak current divided by the surge 2. The same concept here will be applied for the root mean square of the voltage, where V RMS is equals to V naught over surge 2. Okay, so now we have already obtained the value for I naught from question A Roman 1. So we're going to substitute the value here, and then we're going to press our calculator, and we will be getting our I RMS such as 8.49 times 10 to the power negative 3 ampere, also can be written as 8.49 milliampere. Okay, next we are going to look at the third question, where the question asks us to write an equation for the AC current. So before we write the equation of the AC circuit, let us first write the general equation for the AC current. We have general equation for the current in an AC. I is equals to I naught sine omega t, where our current here I is going to vary with respect to the time. As the time changes, the current is also going to change. Therefore, when we are asked to write the equation, what we have to do is we have to substitute the value of I naught and also omega in the equation for the respective circuit. Okay, the I and T is going to vary, therefore we do not have to substitute anything for them lah. So we can leave our answer such as I is equals to sine T here, where the value of I naught we have already got, which is 0.012 ampere. So I'm going to substitute 0.01 to sine, and then omega. As you can see, we have not yet obtained any value for the omega. However, we can find our omega such as omega is equals to 2 pi over the period, where your period is given as 20 millisecond. So this one now becomes 2 pi over 20 times 10 to the power negative 3. So from here we can get our omega as 100 pi radian per second, or also you can say your omega is equals to 314.16 radian per second. Okay, you can leave your answer in pi, or you can give out the whole value. So now we are going to substitute our pi into the equation, omega into the equation, such as 100 pi t. So this is now the equation for the AC current. However, it is advised to mention the unit of the current and also the time here. The unit of the current and also the time in the question, such as where I in ampere and T in second. So that's it for question 1A.